Hello and welcome back to our discussion of cardiac physiology. In this video, we're going to be talking about the cardiac cycle. Okay, so first off, a definition. The cardiac cycle is one cycle of contraction and relaxation in the heart. So basically, what makes up a single heartbeat. Okay. We're going to be looking at all of these events that happen during the cardiac cycle. So we're going to be looking at when the atria and ventricles contract and relax. We're going to be looking at how that affects blood flow through the heart. We're going to be looking at the pressure changes that happen in the chambers during the different parts of the cardiac cycle. And we're going to be looking at what happens with the valves, the heart valves during the cardiac cycle. Okay. But before we go into the details, I want to point out these terms. So we have this term systole, which means contraction. And then we have this term diastole, which means relaxation. All right, let's get into it. Okay, so we're going to start at this point in the cardiac cycle. This point is called late diastole. During late diastole, both the atria and the ventricles are relaxed. And what happens is that blood just flows into the atria as indicated by these arrows. And some of that blood is just going to flow passively into the ventricles. Okay. So that's what happens when we are relaxing both chambers, both sets of chambers of our hearts. Let's move on to the next step. So the next step is called atrial systole. And as you can guess from the name, what happens during atrial systole is that the atria contract, okay? That is going to force some additional blood down into the ventricles from the atria. I just want to point out that in these diagrams, red or pink or whatever you want to call it, indicates contraction. So here you can see that this red in the atria is indicating that the atria are contracting. Okay, so after we have atrial systole, we're going to start to contract the ventricles. And ventricular contraction is actually split up into a couple phases, or at least the way we like to think about it. Is in parts, okay? So the first part is what we call isovolumic ventricular contraction. Okay, so what happens is when we start to contract the ventricles, as we contract the ventricles, we increase the pressure on the blood that's in the ventricles, okay? That blood, because it's at a high pressure, that is going to cause the AV valves to shut, okay? So at the same time, the semilunar valves also happen to be shut, which means that during this phase of the cardiac cycle, the volume of blood within the ventricles is going to stay constant, okay? Hence the name isovolumic, right? So isovolumic means same volume. We're going to have that constant volume of blood in the ventricles during this phase of isovolumic ventricular contraction, okay? So the ventricles are going to contract. They're going to continue to contract, okay? The volume's going to stay the same, but as we push on that blood in the ventricles, that is going to increase the pressure of the blood in the ventricles, okay? I also just want to mention that at this time, the atria are starting to fill again. Oh, I think I have atria are going to start to refill during this phase, okay? Okay, moving on. So remember that we have been contracting our ventricles. That is increasing the pressure on the blood that is inside the ventricles. At some point, that blood inside the ventricles is going to reach a high enough pressure to exceed the pressure that is in the arteries here, the aorta and the pulmonary artery, right? So we're increasing pressure here in the ventricles. At some point, that pressure is going to be higher than the pressure that is in these arteries, okay? That's going to cause the semilunar valves to open. When the semilunar valves open, then the blood can move out into those arteries, okay? And we call this phase ventricular ejection, okay? Meanwhile, I just want to point out that the AV valves are still closed and the atria are still continuing to fill, okay? All right, next phase is isovolumic ventricular relaxation. So when the ventricles finish contracting, they're going to start to relax, okay? As they start to relax, the pressure inside the ventricles is going to fall. As the pressure inside the ventricles falls, what happens is that the pressure in the ventricles is then going to fall back below the pressure that is in these arteries right here, right? So now the pressure in the arteries is going to exceed the pressure in the ventricles. That's going to cause the semilunar valves to close again, okay? And again, notice during this phase, we have both the semilunar valves closed and we have the AV valves closed, which means that the volume of the blood in the ventricles is going to stay constant during this phase, hence the name isovolumic, okay? So, I think that's all I wanted to say about this. Yeah. So we're just going to continue to relax. The pressure in the ventricles is going to continue to fall. Okay. And then eventually the pressure in the ventricles is going to fall so much that it's going to fall below the pressure in the atria. Okay. Once that happens, the AV valves open again and we re-enter late diastole, where we have blood coming into the atria and then flowing down into the ventricles. Okay, so that is our cardiac cycle.